Unfortunately, we still do have lots of problems that need to be solved. And I'm going to highlight a problem to you that it's easy to solve, but it slows things down, so we don't actually have this problem solved. This is a problem that was existing in the old days of video games that you're going to see still today, simply because it takes extra time and memory to solve it. Here's the problem. What if you are in the middle of updating your frame buffer? What if you're updating your frame buffer, okay, into VRAM, let's say. You're right in the middle of it, so bam, and then the monitor gets a new image. Okay, so let me draw this out for you. So this is your frame buffer, and you're updating it. Bam, 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 bam. Oh, right now, I'm going to annotate this. This is my new image. Right? Nice and sparkly. This is my... Oh, come on. This thing likes to turn on the eraser by accident. This is my old image there. Okay? You're in the process of updating it. New, old. Uh-oh. And at this point, the monitor gets a new image. Copy to monitor. Okay. Uh-oh. So what happens is you draw some new image and some old. This is a problem that if you play video games you might be familiar with. It's called tearing. And the reason it's called tearing, because you get this tear line across your display perfectly, where you can see the two images, where you can see that the two images meet. I thought I had a slide on this, but it's not in my notes. There it is. Yeah. So here's an example of tearing. So here's a picture from a game, and you see they're moving quickly. Look here. Here's the new image because the person must have moved to the left, so everything moved to the right. And then the old image is still in the frame buffer. They didn't copy the whole thing over yet. Uh-oh, right? Okay. Where are we? There we go. So that's called tearing. And it turns out that this is a problem that still plagues systems to this day. The standard approach to fixing this is called double buffering. Now with double buffering, what you're trying to do is you might be slow updating your picture, so you work on your own buffer. You make a new buffer. So you work on your image in another buffer in your main memory. The idea is that it might take you a little bit to draw it. You might be a bit slow. So you work on your image in another buffer. It could be in main memory. Sometimes video cards, it could be in VRAM, give you extra memory to work in there. And then when it's ready, you copy the whole thing over as fast as you can. So when the image is ready, you copy the whole image over at once. Overact. Let's try that. Over at once. As fast as you can to minimize that chance of the monitor grabbing it in the middle. This is called blitting. Okay, I suppose I should put them all in BLIT. And the reason it's called BLIT, it stands for block image transfer. So you'll come across this in graphics libraries. It'll say, oh, just BLIT the image. Transfer. BLIT means copy as fast as you can. If you use blitting, you get reduced possibility of tearing. Reduced likelihood of tearing. But you can't guarantee it because unless things are perfectly synchronized. If you do it in hardware, you can guarantee it. Can guarantee no tearing. Now you might think this is simple, just make it wait. But if you take operating systems if you've taken, you'll learn that every time you make something wait, you lose some efficiency. So it actually can be quite slow, or if you miss your interrupt, you can actually slow things down quite a bit. So the more we lock things up and make things wait, you really lose a lot of performance. So this is why this is still a problem. The downsides to blitting and double buffering, of course, is you double your memory needs, right? So a 4K buffer, you have it's a lot of memory, it's very expensive memory, maybe it's right tight to your chip, it can be very expensive. And you also double the memory copy time. Right? Because time 1 is your buffer to the frame buffer, time 2 is frame buffer to the monitor. So you've doubled the number of copies that you need to do. So you lose some efficiency. It's interesting to note that game devices like game consoles, that's the word I was looking for. So game consoles used to have dedicated hardware for this, even in the old days, to make sure you don't have this problem. This is why in the 90s, for example, the era of the first PlayStation, the N64, the Super Nintendo, very smooth graphics. They guaranteed in hardware no tearing. PCs had a lot harder time doing that. So there are a couple solutions to this that I'll talk about briefly. How are we for time? It's getting up there. So there are a couple solutions I'll talk about. One is called wait for vertical ray trace. Vertical retrace. Let's try that again. Wait for vertical retrace. And what that means is, remember back up with our CRT and how the gun fires around? All that does is it tells your computer to, as you know the gun's doing that zigzag pattern, it's going to come back up. That takes a lot of time. That wastes time. And it's not going to be drawing while it's doing that. So you wait for that. It sends you an interrupt. And then you copy during that move, and you can minimize that tearing, okay? It takes time to bring that gun back. Okay, and you can leverage that. Now the other, of course this only works with those old screens. There are some modern solutions, but they haven't standardized yet that I'm familiar with solutions. Feel free to correct me, these things are moving quickly. One way is to have a higher refresh rate. And the reason that this works is if instead of 60 frames a second, I'm going to 120, the tearing that you see in the screen is less, so you notice it less and you have less likely of a chance that you're going to encounter it. There's also brand-specific emulations of this vertical retrace problem. You might have heard of them called V-Sync. That's why it's called V-Sync. Because of vertical retrace. FreeSync is another one. There's G-Sync, and that's what the G stands for, maybe G-Force, I don't know. But people are trying to emulate this to reduce that tearing problem. All right, I think that's a good time to stop. Sorry for the long lecture.